Our star. The sun. The source of our light, all our heat, all our energy.
The sun is really the power source for the entire solar system. So without the sun, life on Earth would probably be impossible. The energy that we receive from the sun is crucial for a start, keeping us warm, for providing energy for the plants to grow. It drives our weather. The Earth would be a completely different place if it wasn't for the sun.
Yet close up, our star presents us with a far more violent picture.
The temperatures are so high at the surface of the sun, humans wouldn't be able to survive. And along with that, the sun doesn't actually have a solid surface. The density is more like that of water, so you wouldn't be able to stand on the surface. You would start to sink in to this very hot, highly charged gas.
We've both worshipped and feared it for thousands of years, but only recently have solar astronomers truly begun to understand our local star.
To really get the best view of the sun, you need to go into space.
We've now put an array of telescopes into space and pointed them at the sun.
I can tell the spacecraft, or in particular my instrument, what to do from anywhere around the world. All I need is an internet connection and a laptop.
Different instruments allow astronomers to look at the sun in different ways.
Today we have instruments which are able to see the visible light coming from the sun. We can see ultraviolet light, extreme ultraviolet light, X-rays, and it is crucial that we have this complete coverage.
Solar astronomers are revealing the secrets of our star.
The sun isn't a perfect and unchanging object. It actually has sunspots on the surface, and from the Earth they look like black features on the surface of the sun.
Sunspots are areas of intense magnetic fields that effectively create a cold spot on the sun.
If you were to be able to cut out a sunspot, though, and put it in the sky, it would have the same brightness as the full moon. It's just that relative to the surrounding surface, they appear dark.
It is around these sunspots that our solar telescopes have revealed even more dramatic events. Solar flares.
You can see that they have loop-like structures, and that's because they're associated to the very strong magnetic fields in the sun's atmosphere. Solar flares are immense, so this one running here would span an area many times the size of the Earth.
Perhaps even more spectacular are a phenomenon known as coronal mass ejections.
They carry about the same mass as Mount Everest into the solar system at speeds of millions of kilometres an hour. The very big eruptions go possibly to the edge of the solar system. What we're looking at here is a fantastic movie which has been made by the Stereo mission. The movie shows us the sun in the bottom left corner here, but if you look, you'll see that there are these white clouds of material that are moving out into the solar system, and these are coronal mass ejections. And the scale I have here is that this material moves all the way over to the Earth on the right-hand side. Using movies like this from the Stereo mission mean we can track coronal mass ejections and the potentially hazardous effects all the way out to the Earth. The way that the sun is viewed today is that it has an outer atmosphere which extends over 10 billion kilometres.
Blocking the sun with a disk shows us more clearly how the sun's atmosphere extends out into space.
We really shouldn't view the sun and the Earth as being unconnected objects. They are connected through the fact that the Earth is sitting in the sun's atmosphere, and anything that happens in the sun's atmosphere affects us here on the Earth.
We call this space weather, and its effect on the Earth depends on where the sun lies in an 11-year activity cycle. This speeded up movie shows how the sun passes from quiet to violent periods of activity.
Now, interestingly, for the last 2 or 3 years, the sun has been at the minimum of the activity cycle. But we are coming out of that minimum now, and the activity will start to ramp up. And we're not sure what the size of the next peak will be, but we certainly do need to follow what the sun is doing so we can try and reduce the effects that this activity has on Earth. And that will include effects on our aircraft, on our satellite systems, on our communications. It could be that the satellite that your mobile phone is using fails, and also our electricity networks as well. The sun is really an object that we need for our day-to-day lives, but it is also an object that can destroy aspects of our day-to-day lives. So we kind of love and fear it in equal measures, maybe. And really, we should be respecting the sun, and in particular, we should be studying it to understand what it's doing.